So, in the previous lecture, we have seen some of the singularity functions like unit step function, unit ramp function, unit impulse function, and impulse train. Next, we will see the remaining singularity functions. So, the next singularity function is unit rectangle function. Unit rectangle function. Unit rectangle function. First of all, let us see the graphical representation of unit rectangle function. So it is represented as RECT of t. This is my rectangle function, and it is varying between minus 1 by 2 to 1 by 2, and it is having an amplitude of 1 between minus half and plus half. Okay. So this is a unit rectangle function. So the area of this is 1. That is, this is half plus half 1. So width is 1, height is 1. So 1 into 1, it is equal to 1. Okay, that is why you call it as unit rectangle function. So let us see the mathematical expression for this rectangle function, that is RECT of t is equal to, now outside this it is 0, inside these limits it is equal to 1. So 1 for mod t less than half. Mod t means if I remove the modulus, it is plus or minus half. So between minus half and plus half, it is equal to 1. And at plus half and minus half, its amplitude is 1 by 2. Okay, so here at t is equal to minus half seconds and 1 second, its amplitude is equal to 1 by 2. So 1 by 2 for mod t is equal to half. And outside this it is 0. So 0 for mod t greater than half. So this is what is my unit rectangle function. Next we will see unit triangle function. Unit triangle function. So first of all, we will see the graph for unit triangle function. So it is represented as TRI of t, triangle function TRI of t. So between minus 1 and plus 1, it is changing linearly. So it is a straight line. Okay, from minus 1 to 0, it is increasing linearly. From 0 to 1 second, it is decreasing linearly. Okay, so what is the area? Half into base. Base is 1 plus 1, 2. So half into 2 into 1, so it is 1. So the area is 1. That is why you call it as unit triangle function. So the triangle function mathematical expression TRI of t can be given like this. Okay, it is equal to 1 minus mod t for modulus of t less than 1. Okay, that is when t is 0, it is 1. When t is 1, 1 minus 1, 0. When t is 0, it is 1. When t is minus 1, minus of mod 1, 1 is 1. 1 minus 1, it is 0. So between these two, it is changing linearly. Outside this, it is 0. So for it is 0 for mod t greater than 1. Greater than 1 means t greater than 1 or t less than minus 1. So it is equal to 0. So this is what is unit triangle function. And the next one is unit sinc function. Unit sinc function. So unit sinc function defined as SINC of t is equal to sine of pi t by pi into t. So this is what is the sinc function. Sinc of t is equal to sine of pi t by pi t. Some textbooks follow other notation like sinc of t is equal to sine of t by t, sine of t by t. But we now follow this notation or this function. Sinc of t is equal to sine of pi t by pi t. Now let us try to draw this sinc function. For drawing the sinc function, we should know the value for different instants of time. Let us say we'll find the value at t is equal to 0. At t is equal to 0, this is in 0 by 0 form. That is sine of pi into 0 is sine 0. Sine 0 is 0 by 0. When it is in 0 by 0 by form, what we have to do? We have to use L'Hospital's rule, that is limit t tending to 0, d by dt of sine pi t, which is pi into cos pi t by d by dt of pi t. So it is equal to pi, so it is cos pi t. So when t is tending towards 0, cos of pi into 0 is 1. Okay, so at t is equal to 0, the sinc function is 1. For the remaining instants of time, let us say when t is integer, when t is equal to 1, sin pi is 0, 0 by pi into 1 is 0. When t is 2, 2 pi, sin 2 pi is 0. So for integer values of t, it is equal to 0. So let us try to draw this sinc function, that is sinc of t. Okay, so at t is equal to 0, it is 1. Now it keeps on changing like this. So this is my sinc function as a function of time. So at t is equal to 0, it is 1. At 1, t is equal to 1, it is 0. At t is equal to 2, it is 0. At t is equal to 3, it is 0. At minus 1, at minus 2, and so on, it is 0. Because when t is an integer value, here, sine of pi into 1, sine pi 0, sine of 2 into pi, sine 2 pi is 0, sine 3 pi is 0. So 0 by some value, pi into 1 means 0 by pi, 0 by 2 pi, it is 0. So the 0 crossings will be for integer values of time, that is t is equal to 1, 2, 3, 4, and so on. You will have 0 crossings. Okay, so here also we have for minus 1, minus 2, minus 3, and so on, we will have 0 crossings. So this is what is my sinc function. Now the last function is a Dirichlet function. So this is the last one which we are going to see now. So Dirichlet function represented as drCl of t comma n is given by sine of pi or n pi t by n into sine pi t. So this is what is a Dirichlet function. drCl of t comma n is equal to sine n pi t by n into sine pi t. This is called as a Dirichlet function. Now if I want to draw this Dirichlet function, I should know the value of this for different instants of time. Now if t is an integral multiple of 1 by n, integral multiple of 1 by n, then 1 by n into 1 by n will be n gets cancelled, sine pi is 0. 2 by n, sine n pi into 2 by n gets cancelled, sine 2 pi is 0. Okay, if n is an integral multiple of 1 by n, then my drcl of t comma n is going to be equal to 0 because the numerator is going to be 0. And if n is an integer, then sin n pi into t integer, some sin 2 pi n, it is 0. Sin pi into 2 is 0, 0 by 0 form. Then I have to make use of L'Hospital's rule. What is L'Hospital's rule? Limit t tending to 0. I have to differentiate both numerator and denominator. If I differentiate numerator with respect to t, then what we are getting? N pi into cos n pi t by, so n into differentiation of sin pi t is cos pi t into pi. So pi into cos pi t. Okay. So here if n pi is getting cancelled, then limit t tending to 0 cos n pi t by pi t. And this is equal to plus or minus 1. Okay. So limit t tending to, sorry, here m is t is an integer. Integer means t tending to m, where m is a integer. For all integer values, it is going to be equal to plus or minus 1. Now let us see when it is plus 1 and when it is minus 1. Let us say if n is even, let us say n is equal to 4, then cos of 4 pi, okay, by cos pi t. Okay, let us say t is equal to 1, 4 pi into 1 by pi. Cos 4 pi is 1, cos pi is minus 1. Okay, so if n is even, then it can be either plus 1 or minus 1. So the Dirichlet function, my drcl function, can take either plus 1 or minus 1, because if n is equal to 4, cos 4 pi t by cos pi t, 4 pi into 1, cos 4 pi is 1, but cos pi is minus 1, 1 by minus 1 is minus 1. So it is going to take either plus 1 or minus 1. Or if n is equal to odd, if n is odd, let us say n is equal to 3, then cos 3 pi t by pi t, cos 3 pi into, let us say t is equal to 1, cos 3 pi into 1, cos 3 pi is minus 1, cos pi into 1, cos pi is also minus 1. So minus 1 by minus 1, it is going to be plus 1. So if n is odd, my drcl is always taking positive values only plus 1. It is not having any negative value. Okay. So based on this, we will try to draw this Dirichlet function for two different cases. That is when n is even and when n is odd. For when n is even, let us say drcl of t comma 4, I will draw. Then when n is odd, then I will draw drcl of some other odd value, let us say t comma 5. So the function will be something like this. So it is going to take positive as well as negative values. Okay. So here also like this. So this is my 0, this is 1, this is 2. Okay. So this is 0, this is minus 1, this is minus 2. Okay. So it is going to take a value of 1. So when n is even, it will take either plus 1. So here it is plus 1 or it is taking minus 1. Okay. But when n is odd, it will take only positive values. That is, I can draw it like this. Okay, like this. So it is going to take only positive values. Like this. Okay. And so on. So 0, at 1 it is positive and it is equal to 1, at 2 it is equal to 1, at minus 1 it is equal to 1, okay, and at minus 2 also it is equal to 1. So this is what is my Dirichlet function for different values of n. So this is the case when n is equal to 4, that is even case, and this is the case when n is equal to 5, that is odd case. Okay, so I think you understood this point here. When n is even, so denominator is even multiples of pi, so it is always 1. But the numerator is even multiples of pi, so it is always 1, whereas denominator will be either even or odd depending on the value of t. So it will change between plus or minus 1. When n is odd, denominator is odd multiples of pi, and odd multiples means whenever t is 1 it will be odd, t is 3 it will be odd, t is 5 it will be odd. So both of them will have minus 1 values. It will become plus, so it will always stay positive 1. Okay, so here it is always plus 1, whereas this one is changing between plus 1 and minus 1. So this is what is my Dirichlet function. So this completes the various continuous time functions, under which we have covered exponential functions, sinusoidal functions, and various singularity functions. Thank you.